Welcome back. In our last two sessions, we discussed the role of analytics in the supply chain, and we focused about the predictive analytics, that how we want to determine that on the basis of past what can happen in the future, and what can happen in the future. This is also linked with lot of uncertainties. If there is a well defined period, what has happened in the past, accordingly things will happen in the future. But we all know that future is full of lot of uncertainties, and therefore we will talk of uncertainties in today's session. I can take you to the situation before 1990s. In most of the pharmaceutical companies before 1990s, the environment was very much certain, and companies used to have dedicated capacities in their plants. The meaning of dedicated capacity was that in a particular plant you will have the entire facility dedicated for a particular kind of medicine. But nowadays, if you go to a pharmaceutical company, you will find that most of the companies are having flexible capacities, because it is highly uncertain that what kind of problems will be there, and problems means what type of new diseases will be there, and accordingly you will require new types of medicines, and therefore on a very fast basis your salts are changing, and accordingly the new types of medicines you need to manufacture in the same plants. So therefore flexible capacities are required, and these things are the subject matter of uncertain environment which are going to be there, and we will discuss some of the specific cases, that how some of the tools can help us to handle the issues related to uncertain environment. The type of uncertainty which we are going to discuss, that is binomial representation of uncertainty. There can be normal representation of uncertainty also, but in this session we are going to discuss the binomial representation of uncertainty. So we are going to discuss the binomial representation of uncertainty. In the binomial representation of uncertainty, there can be two cases. One case where we have the multiplicative uncertainty, and in another case we can have additive uncertainty. This slide gives us the example of multiplicative uncertainty. Now there can be uncertainty with respect to so many factors. Your demand may be uncertain in the future, your price of the commodity may be uncertain in the future, the exchange rate may be uncertain in the future, the supply can also be uncertain in the future. So you can take any underlying factor at once to understand the method of solving such type of situations. So here I am taking one underlying factor, that is price, and I am representing that price with capital P in my starting time. At time t0 my price of the commodity is P. Now price can increase or price can decrease in the subsequent periods. So I am taking two factors, one is small u, another is small d. Small u is greater than 1, that price is increasing. If I am multiplying this small u with my capital P, so that is the increased price in the next period, and d, small d is less than 1. If I multiply capital P with small d, the price is decreasing in the next period. So for example, if price can increase by a factor of 5%, the value of u is 1.05, and if I say that price can decrease by a factor of 5%, so the value of d is 0.95. So if price P is in time t0, so in time 1, period 1, the price can have two values, Pu and Pd. So, if P is 100, so that is 105. If PD is there, it is 95. Now, since it is uncertain environment, the probabilities are also required. So, the probability is small p for this u and 1 minus p for this d. So, the chances of getting this price pu is having a probability of p, and chances of having this price pd is having a probability of 1 minus p. Now, going further in the next period after period 1, pu can further increase, pu square it can become, and pu can decrease by a factor of d also. So, pu can become pud. Similarly, pd can also increase with a factor of u. So, pd can become pud, and pd can further decrease with a factor of d. So, pd can become pd square. Then pu square, which is there in the period 2, can further increase with a factor of u. So, it can become puq, and pu square can decrease with a factor of d. So, it can become pu square d. PUD can also increase or decrease. It will increase with a factor of u, it will decrease with a factor of d. So, when it increases, it becomes pu square d, and when it decreases, it becomes pud square, and so on. For pd square, it can also increase or decrease. When it increases, it becomes pud square, and when it decreases, it becomes pd cube. And similarly, from period 3, when we move further to period 4, pu cube can also take two values. It can increase with a factor of u, it can decrease with a factor of d. So, it will take pu cube to pu4 and pu cube to pu cube d. Pu square d will take pu cube d and pu square d square. Pu d square will take two values, pu square d square and pu d cube, and pd cube will also take two values, pd4 and pu d cube. And you can go for period n also by doing such type of calculation. Each time you have two possibilities, each time you have two possibilities that your present underlying factor may increase or decrease, and probabilities of increasing are p and probability of decreasing is 1 minus p. Now, these are the way in which you can write on a generic basis that how things are going to change in a multiplicative binomial representation, and this gives you a very general type of understanding. If you recall the previous slide, that the possibility can be represented as p u to the power t into d to the power capital T minus t for any particular t from 0 to capital T. So, for period t, for period 2, period 3, period 4, you can find all possible outcomes in this manner, and therefore, it is also very simple to understand that at period 0 we are having this price p. At period 1 the price may take two values, that is pu and pd. So, for that let us go back to the previous slide. So, the price is taking two values pu and pd. Further, in period 2 pu may take two values, one is pu square and another is pud. When this factor is decreasing, you can see on the screen also. Similarly, pd will also take two values, one when it is increasing it will become pud, and when it is further decreasing it becomes pd square. Going to the third period, Pu square may take two values, it can increase, so it becomes Pu cube, and when it decreases by a factor of d, it becomes Pu square d. Similarly, Pud can also take two values, it can increase, and when it increases it becomes Pu square d, and when it decreases it becomes Pu d square. Similarly, Pd square can also take two values, it can increase, when it increases it becomes Pu d square, and when it decreases it becomes Pd cube. And you can simultaneously match the development of this kind of branch diagram with the uncertain values of our underlying factor which we have given on the slide. Then further, if I go to period 4, Pu cube will also have two possibilities, that is Pu4 if it increases, and if it decreases it becomes Pu cube d. Pu square d also has two possibilities, if it increases it becomes Pu cube d, and if it decreases it becomes Pu square d square. Similarly, Pud square also has two possibilities, if it is increases it becomes Pu square d square, and if it decreases it becomes Pu d cube. And similarly, Pd cube also has two possibilities, if it increases it becomes Pu d cube, and if it decreases it becomes Pd 4. And you can match this diagram with the values which we got. So, this is a very simple way to develop the uncertain environment. This is a very simple way, and just by going into the SEM method you can develop this diagram. And therefore, the next slide which gives us the idea about how you can have a generalized representation of any state in the development of this uncertainty diagram, that is Pu small t d to the power t minus t for a particular period capital T. Capital T can be period 1, period 2, period 3, period 4, and in these periods you have variety of states, and these formula will help us to go for all those different types of states. There are in each of these things, in a particular period from this state the price may move in increasing or decreasing order. You see, let us say in state 2 PUD at time 2 PUD is a state. Now from PUD price can increase, it becomes Pu square d, price can decrease, it becomes Pud square. So both these movements are possible. So this is again the generic representation of two possible states, that the probability of increasing the price is P and probability of decreasing the price is 1 minus P from a particular state to the next time interval. So this is the generic representation of uncertainty, and this is the specific movement in this particular case. This is about the multiplicative uncertainty. In most of the cases in our supply chain decisions, we will be using the multiplicative uncertainty. That uncertainty is increasing or decreasing as a multiplying factor to our underlying factor. It is also possible to have additive representation of the uncertainty. In that case, these P will have addition of this factor u, and this will have negative of the D. So, it is P plus U, the underlying factor is increasing by U and underlying factor is decreasing by D. So, you are adding and subtracting a fixed quantity from your underlying factor. So, if this type of issue is there, it is the additive representation of the uncertainty. So, similarly you can go for all subsequent period if you want to use this P plus U or P minus D. So, all these representations will change and we will have a new table for representing the additive binomial uncertainty. But there are certain cases where it is not possible to have the additive binomial uncertainty, particularly in case of price, demand, etc., which are very important in case of supply chain. Because when you have, you all can understand, when you have this additive or subtractive values plus U minus D, you can reach to negative values also, and it is not possible to have negative demand, negative price, etc. You can understand, for example, if a price is initially rupees 10, if price is initially rupees 10 and you are talking of a uncertainty that price can increase by plus 2 rupees and price can decrease by minus 1 rupee. So, in that case it is possible that if you talk of this type of lag P minus D, P minus 2D, P minus 3D, P minus 4D, P minus 5D, and in 11th period it will be P minus 11D, and at that time price will be negative. At that time you can imagine a situation where the price will be negative, and that is not possible. That is not possible. You cannot have a negative price. Similarly, demand is also there. You have initial demand of the product, let us say 100 units in a particular time period, that in month 1 you have the demand of 100 units, and there are values of plus 10, minus 15. That demand can change by 10 units or can decrease by 15 units. So, if I talk of this last leg, there may come a time where demand may go for the negative values. So, that is also not possible. So, many a times you will see, because our underlying factor cannot take the negative values, it is not possible to use additive binomial uncertainties. So, we will use in most of the cases the multiplicative binomial uncertainty. Then there is another reason for that. One reason is this, that you cannot have the negative values of underlying factor. The other factor is that it is not possible to have some kind of change in a very small time. Like for that period purpose, if my price of a product is $15, my price is $15, in that case it is not very appropriate to say that price may change by a factor of, let us say, $5. It is very you can say thing which is not possible. It is not appropriate to say that price can change by a factor of plus minus 5 when the original price is $15. However, same thing makes sense if the price is $500. If the price is $500, in that case if I say that price can change by plus minus $5 in a period, it makes sense. So, you need to see that what is the size of my original underlying factor, and in that case probably you can use the additive uncertainties. But if the size of the original underlying factor is relatively small, again it is not advisable, it is not possible, it is not good to have the additive uncertainties, because you will not have this type of fixed values which can be added or which can be subtracted from the original underlying factor. So, whenever the size of the initial underlying factor is relatively small, we go for the multiplicative binomial uncertainties. So, that is another important reason. So, two things are there, that sometime your underlying factor cannot take the negative value, which probably are possible in case of additive uncertainties. So, you will not take those things, and when the size is also small, it is not advisable, because in that case fixed uncertainties are not possible. So, uncertainties are percentage of the original values. So, in that case also we will go with the multiplicative type of binomial uncertainties. Now, once we are clear about this representation of uncertainty, binomial representation of uncertainty, it is also important to say that here we are only taking two possibilities, that price can increase either by a factor of u or price can decrease by a factor of d. So, when my original price is p, it can take only two states, pu or pd, but in real life it is not so. In real life price can increase by different values, price can increase by u1, u2, u3, there are different probabilities for increasing the price from p to pu, pu1, pu2, pu3. Similarly, price can decrease to d1, d2, d3, there can be different underlying factor, different values of d, that d1 is 0.95, d2 is 0.96 and d3 can be 0.92. Similarly, u can be 1.05, u2 can be 1.07, u3 can be 1.10, and you will have different probabilities for all these things, that the probability of u1, u2, u3, d1, d2, d3 are different from moving p to that state. But here we are considering only two states. So, there are two reasons for that. One is that we are just learning that how to incorporate uncertainty in our discussion. So, for that purpose it is easy to take only two states, that is one answer. The second answer is that though if your time period is slightly long, then all these u1, u2, u3, d1, d2, d3 will come. But if you take a very small time period, then probably you can divide the uncertainties only into two states, u and d. So, this type of situation can also be taken practically. It is not only just for the academic discussion, it can be taken practically also, but then we need to take the very smaller time period where you can only think of two possibilities, whether u or d. As you increase the time period, you will have chances of different states with different probabilities. All those things can also be handled, but that will be slightly more complicated model, and then thanks to IT, thanks to computer science, these things will help us in handling those complex situations also. So, if I reduce my time period, if let us say I am doing the determination of pricing on the monthly basis, probably u and d is fine. If I take demand factor on a weekly basis, u and d is fine, but if I take price on yearly basis, then probably u1 to u3 and d1 to d3 can come. So, I need to see that what is the optimum you can say time period for taking this into my account, so that u and d, only two possible states are required. So, these are the initial things, and when you do this binomial representation of uncertainty for fairly small time period, and you do it for a long time, you have t equals to n and n is fairly large, then this binomial representation of uncertainty becomes almost equal to normal distribution of uncertainty. So, that is also important to understand that then it is nothing but simply the normal distribution. So, we should take in better decision making, better predictive analytics, we should take smaller time periods and a smaller time period for long time, so that you can have the normal distribution of the uncertainty in the long run. So, with this background, now this is the additive representation of the uncertainty, just as we have discussed. If initial underlying factor is p, so it can take two states pu, p plus u and p minus d, and similarly as the explanation was there for the multiplicative uncertainty, p plus u will again have two possibilities. So, if it is increasing, it becomes p plus 2u, and if it is decreasing, it becomes p plus u minus d. Similarly, p minus d also has two states where it can increase or decrease. So, when it increases, it becomes p plus u minus d, and when it decreases, it becomes p minus 2d. I am not going to discuss the state 3 and period 4. I request the students that you write that what will be the different states when we are moving in the same way for the additive uncertainty, and try to match your answers for what we have written on the slide, that these are the different states in period 3 and these are the different states in period 4. So, please do not see these two lines and try to write on your own, and then you can match that whether you are also getting the same kind of states for period 3 and period 4. And again, the simpler way of achieving these states is to go by this type of tree arrangement, that how you are getting different types of states during the different time periods. So, this will help you to achieve that tree for the additive uncertainty. And here also you have generic representation of additive binomial uncertainty, that t has all possible outcomes at a time period t, that is p plus tu minus t minus t into d, and for this t you can have all possible states from t equals to 0 to capital T. So, that is the way you can develop your different states for a particular time period capital 2. So, like for an example, if I take capital T equals to 1, if I take capital T equals to 1, so your different possible outcomes using this binomial representation are p plus tu minus t minus small t into d, and I will take two values of small t, and these two values of small t are 0 and 1, and capital T is 1. So, possibilities are p, this t is 0 first into u minus t is 1 minus 0 into d. So, one state becomes p minus d. The other state, the next time I will take the value t equals to 1. So, this becomes p plus 1 into u minus capital T is again 1, small t this time I will take 1 minus 1 into d. So, this becomes p plus u, and you can see that at time period 1 we have these two states p plus u and p minus d. So, similarly you can determine the states for any time period using this generic representation of additive strategy, additive uncertainty. But the additive uncertainty, as we discussed, can only be used where we have large size of our initial underlying factor. So, we stop our discussion at this point, and in our next session we will take a numerical example to discuss the role of uncertainty in predictive analytics. Thank you very much.